Testing, testing, 1, 2, 3. Let's see if this is reporting anything new. Testing, testing, 1, 2, 3. Okay, great. How's sound? That's good. Sorry, I back one. So, this lab is to create something akin to this here. A cube that is, well, fucking rotating. I don't know it's rotating. Let's just have a rotation. So a cube like this, in that the colors fade from one to the other. We're supposed to do this. The way that the color cube, the cube.c file works, is it uses vertices, normals, and the colors at the vertex. You can see it broken into 3 segments each. So the colors, the normals, and the at certain points. However, our lab, if I open up the actual, here we go. It's not that one actually, it's the lab sheet 11. So, our task is to create fluency to simulate what it does internally. Particularly this part here. They want us to create this image here without using the tools that they gave us in cube.c. Basically, we've got to go the long way around and figure it out. So, this is how we do it. For any line, we can calculate the intensity, and intensity in this case is just another word for RGB. And all it is the, so you see Y-form, this horizontal scan line is made with only the Y's. And then there'll be a vertical scan line on the red dot point P that only uses X's. This allows us to fairly easily figure out what any point is colored at. And just to show you roughly what the end result is, I'm just gonna run, hopefully I set it to back to normal. Yeah, this is what you're supposed to get. Quite nice, isn't it? The reality is it's made up of hundreds of thousands upon thousands of points in it. And so I'm gonna yank this to the side. I'm gonna put, yeah, this here, and just spread a little to the right. So this function, this formula, is always on screen for me because I'm lazy. Lazy is good. Lazy is really good. So, to do it, I created a new file and I've eaten in some of the basic stuff. So, you know this stuff from previous labs that we've done. Minimum shape function, you know that. And then the only new part is this function here, controller. the lab asks us to fuck off you to, where is it? So vertices 0m minus m0 blah 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 2m, and you set it for m. So for me, m is a variable, and I'm using 15 as my standard one. So to begin with, here and begin, and we're going to use points. Label out the vertices, label out the colors. Notice, fuck off you. Notice for red it's RGB, RGB, and then black is no color, because unlike reality, where black is every color, basically want no light back at all. So 0. White is 111. So basically with that, I figure out small little one here, and you get the Y min, Y max from here. You need to know the bounds. Like, yeah, I know it is technically minus m to 2m is the x, and minus 2m to m for the y, but never trust, only verify. I'm going to turn down the music a tad. Testing, testing, yeah, there we go. Should be able to still hear music, but not too much. Okay, and also, because I'm an idiot, I'm just going to use the same naming scheme as this diagram here. So 1, 2, 3, and the other point is going to be 4. And there's going to be a special way to deal with 4 later, but I'm making use of the fact that all the items are on the x and y axis. Oh, this popcorn is good. So, first I want to start at the smallest y value. That means my x value, as I go from, say, 2 upwards, or the line that 2 is on up. And I need to get this formula. So I'm just gonna type out the formula. I4 is equal to, well, I4 is going to be an interesting type, and come back to it in a second. Equals a ratio from 4 to 2. 4 to 2. It's going to be the left hand side, and then that's multiplied by I1, and yeah, it's red text, I know, but this is how you roughly lay things out. And I'm gonna have to do the right hand side. Just left hand side, right hand side by L2. So that is looking very red. So what is the ratio on the left hand side? Well, it is a float. Well, let's see, is it float or double? Yeah, it's float. Equals y4, in this case it will be just y, because that's the value we're using. So 0.4 is on the line that is y, and so brackets y minus y2 over y1 minus y2. Oh yeah, I know, that's right. And the left hand side is going to be similar. Left. Oh, right hand side. And that is y1 minus y4. y1 minus y. And the base is the same. So now you're beginning to see that there is some interesting things going on, in that there's red still. So we have to fix that. So y1, what is y1? y1 is the y coordinate is a float. y1 is equal to this float here. So vertices 1, x is the first item in it, and y is the second. So 1, y1, that's sorted. y2 is going to be similar. And which one is 2? So 0, 1, 2. 2 is 2. Let's make that tidy 0. And we're still missing what else? L1 and 2. L1 is the color at I1 is the color at 1. So illumination at 1 is the color. So float star, because it's array and we're just using it temporarily. I1 is equal to colors 1. And we're gonna need to do the same with I2, and we know that for sure. And yeah, you can see that there's probably going to be a bit of an issue there. So how do I do it again? It's float I4. Now, because we are doing a scalar multiplication of an array, it is simply this value here by all the value, every value in I1 is multiplied by this value. Or you can break it up. So I'm going to just comment that out because it's going to be useful to come back to. So in this one, the illumination at I4, there's going to be 3 values in it. There's going to be odd, red, green and blue. So 0, 0, 0 as placeholders, because I sure like placeholders. So it's the ratio. So the way it works is the ratio of L1 or I1 plus the ratio of I2. So it is ratio I1 by I1 0. So that gets the first item. And because I do not trust anything unless it's in brackets, properly detailing where it goes, I'm going to put that in brackets. So, and then the right hand side is multiplied by I2. You can begin to see how this goes. Oh. I1, 1, 2, and 2. So you can see how this takes each component of the parent illumination values, so R, G, and B, to figure out what the child, in this case I4. And now we need to do the same with I5. I5 is the one on this side, and we're going to do copy paste because again lazy. So 5, 5, 5, copy down stuff because again lazy, and it is 2, 3. So it is 0.3 that we need, and every place where there is 1 in the first one is now a 3. So you can begin to see how things just begin to lay out. So what is Y3? Well, Y3 is again third element. I was either a genius or an idiot for choosing that naming scheme. And then float I3 is also in the third position. And so I have I4 and I5 generated there. And what that does is it gives me essentially a rectangle, or rather a point on either side of a rectangle going up along, and that we know the colors for. That is the y-axis essentially. We now have to do the x-axis where we go across. So that's the up, means go across. So, oh fuck, my nose is itchy as fuck. Coffee's good though. That's nice. So, across is the next part. So, similar to how we did this, and then we're lazy again, and x equals x min, x is less than x max, x plus equals the increment. And come to increment a little bit, will be visible. And so, now we have essentially 4 and 5. We can use the x values to get p. And that is a relatively simple thing if you copy and paste. So, let's just copy this one. Makes more sense thematically. So, 4 to 5, left hand side, 4 to 5, right hand side, copy them down, because again, lazy, should always be lazy in this sort of thing. IP is equal to that. And now the left hand side is I4, so we need to copy this illumination and paste it in there, because that's the component of that, is the left hand side of the equation. The right hand side is I5, and you can see those light up now, that's lovely. And then we've got to fix the formula. So the formula is x5, which is one sec, let me just, so it's x5 minus xp. Oh yes, so a good thing to note is that 5 is x max. So x5 minus x, and it is xp minus x5 minus 4. x5 x5 minus x4. So it's getting the distance from between here and here, since 5 will always be positive in this case. Again, laziness. And to the top, the other one is x minus x4. X minus x4. Now, the interesting quirk here is that x4 is equal to x min. Because what we're essentially doing is, you see this scan line here? There's going to be a horizontal scan line. Can I actually draw? Yes, I can draw. I need to have it as red. Okay. So, there is going to be horizontal scan lines going like this. So it starts at 4. Starts at here, which is the x min, and will end at the x max, which in this case will be where 3 is. So x4 is x min, and float x5 is equal to x max. And you see, that worked out. Now the very simple thing then is we've got to plot the point. Where's my code again? Root. So x and y. So we've got the x from up higher, the y from here, and so we know the color at that point, and we know its coordinates. And when I press run, it should be a nice, lovely rectangle. And it's only just 2 colors. Why is it 2 colors? Ooh, yes. Yes. So, this is a side effect of this simplistic way of doing it. See 2? So I'm just going to group things together just to make it a tad easier. So you know how I've got only 3 points here? That is a side effect of the way I'm handling things. So we can only deal with 2 things at once. The 2 lines that we're pairing off of at once. There's probably a way to do more. I'm not smart enough for that. So my trick was, since this is essentially, since the shape that we have to do, can I just get you to run, please? Because then I can show it. Because it's so much nicer visually. Since this is basically an upside down triangle, like what we see here, since it's an upside down triangle, we can use these points perfectly. And then it flips up, so point 4 has got the same 1 and 3 as its core points, and it also has its own. So I'm just saying in my code that point 2, when it's above the line, it has the same coordinates as point 4, so it flips around. It's not perfect, but it should do well enough. So if y is greater than 0, y2 has to be 0.4, which is, in my case, 0. And so, because I'm lazy, I can't be reassigning them there, is equal to 0. Your actual indexes of stuff will vary depending on what order you lay stuff out. Be warned. So, oh wait, that's not that one, it's the lab 3. I have to rerun. So, this on the left is the finished product, on the right is what it's supposed to look like. And that looks a tad off still, which is weird, since code should be basically identical. What did I fuck up? I probably fucked up something. Let me just run this again. I kind of feel like I have things reversed. For 5 left hand side, it's what the fuck? Well, I probably should just clear the cutting to be able to see things a bit clearer. Yeah. Where's my black? Oh wait, do I have green twice? RGB. So colors, do I have 2 there twice? Fuck. As you can probably tell, I haven't got scaling right on this. It works with me okay, but I'm gonna yank this over and compare. Hey hands. Only just noticed you now. No real need to donate anything, especially if I'm not getting stuff right. This lab has been tricky as fuck for me. How do I view? Oh yeah, I need timestamps. There we go. 15, 16, 17, and live chat. Yeah, there we go. Okay, so I'm just double checking my own code. One is one, that's all good. 2 is 2, and was it 0? That's all good. And 3 is 3, that's all good. So code-wise, am I comparing? Y minus y2, y1 minus y, I'm on the left. I hate finding bugs like this. So a4, left hand side is start, right hand side is that. It should be 5 is... Oh, feck, yeah. Found my problem. Ah, tiny bugs. Tiny bugs. It's always the tiny stuff. Always the tiny stuff that gets you. So, this is I1 to I3. It's supposed to be I3 to I2. And if I run this one now, it should come out as the right colors. Yes. And I'm just gonna set the increment back to 1 for visibility. So, this is what this code here gets you. And where is the other one? Come on, Tux. No, I don't need you, color cube. And other piece of code is here. I need to undo the changes and rerun it. So, this is what the current code gets you. There's a few things you can play around with. Most notably is I'm not going to tell you how to get the nice smooth lines here. That's parts for you to figure out. Because that's fun. If I zoom in, or could zoom in, you would see plenty of jagged pixels. So, any questions, folks? And oh boy, it seems like cutoff really. Ha! The cutoff is interesting. You have to figure out with a certain y value where the x value of the line is. Yeah, the left hand side is what this code generates. The right hand side is the trimmed corners. The trimmed corners and a few tweaks to like increment here. So the way it works is like you've got a backing grid behind it, kind of. Well, you can probably see it clear if I change it to 2 and run. So if I set it to 2, you can see that it's very much like a grid, where you go across, then up, up and across, and it's grid is that way. When you change it to say 0.1, 0.1, because you will complain otherwise, it gets finer detail. So it's still a lot of tiny dots there, just too small to see. Of course, if you really wanted to be bonkers, you could probably change it to that and 0.01. And of course it dies. Oh no, just takes a lot longer to calculate. Because don't forget, it's not a 10-fold increase when I change it, because I'm using it for both the x and y. It's 100-fold. So 0.1 I find is a nice sweet spot for it. And so you can see roughly where the points are, because like that's the green point. The red point meet up here somewhere, the black point is there, you can actually see how black is not really light, how easy it fades into other colors, because it's the absence of all other colors. When you toss in some light, some color, it kind of vanishes easy. And then the blues down here. Yeah, it's kind of like that. So, in my one, when I was plotting the points here, it was at this point here that I questioned if the point should be plotted or not. So I have the x value of the point, well, x and y value, and because I know the lines that it was going to, you can figure out, is it to left or right of the line. It's not perfect, as you can see, like a bit of squareness up there, but it's good enough that it doesn't really matter too much. You could do like there's probably an OpenGL function for clipping on a line or something like that. I don't know. Any other questions? So it's basically, in summary, this formula here put into practice. And because we're told exactly what shape it is, I'm cheating a bit by saying that 1 and 3 will never change, and as soon as you go above the y-axis, what it 2 will become the coordinates of 4, just for ease of use, because then I don't have to change any other formulas down here. I'll probably throw this up as a gist or something, just so that folks have a rough and throw it up a gist, maybe with some of the details stripped out, some of the comments or whatnot, so it's a bit bare bones maybe, I don't know. And yeah, there is one part of the lab that I did not do. This bit here. See this entire segment here? I'm not doing that. I just can't be asked, because what are our labs again? It's small enough. All in all, it is, where's the marks on the so labs are worth 5% each. So that's like an extra 1%, and I can't be doing that. So it basically is where instead of can I draw again? Yes, I can. So this is the current-ish shape, and can you make it again work? The black point 2M, which is here, is moved to up here. I'm gonna change you to red. Oh, no, I don't want you to go. And there we go. So, no, shut up, you. No, come on. Is basically changed to here. And there. This has the complication of you have to figure out which point it's going to. You have to dynamically figure out stuff. And by God, my drawing is terrible. For clarity's sake, let me just draw the axis this way. So This is a terrible axis, so that's roughly x and y 1. Just don't take it as fact. Just not worth the effort for 1% extra. Well, it may not even be 1% extra for us at this point. Yeah. Any other questions? Okay, if there are no other questions, I am probably gonna finish up and see if I can get a gist of this up for folks to see. Yeah. Right. I don't think there's anything else. Oh, and although this one may have been annoying, the actual bonus one is really nice. So the bonus one is interesting in the way that the bonus is originally the week 10 one, and one we're doing now is the week 11. So they kind of just switch the order around, and week 10 one is really nice in that you just, what is it, C? Oh, there we go. So C, press there and there. Right click, pen width is like 888. Pen color, change to blue, and I don't know why it keeps resetting. I think it's to do with the clicking and whatnot. So the key problem I had with this was just how to resize it so that nothing on screen gets bigger or smaller. A slight headache to figure out, but R is rectangle, and it's that. R rectangle, yeah. Because of scaling and whatnot, it's not so nice to do it, but it works. Any questions about that? Because oh god, the stream is so far behind. I'm looking at it in the preview window. Right then, I'm gonna take that as a good night for you folks.